Here are some instructions to help you out with Lab 5, Earth-Sun relationships. These are the first 2 pages of what I've assigned. I've had you skip activity 1. It's a little bit of an annoying problem. I usually help students quite a bit one-on-one in class, and so we're going to just move on to activity 2. I do want you to read this text here on page 146 because it's going to remind you about the important concepts related to the seasons. Some of these include the significance of the equator, the Tropic of Cancer at 23.5 degrees north, and the Tropic of Capricorn at 23.5 degrees south. You've already learned the significance of these various lines of latitude, but this lab will help you solidify those concepts in your mind. Part of the reason why we have these tropics of Cancer and Capricorn is because there are various times in the year when the vertical rays of the sun strike that particular latitude. And so in the northern hemisphere, when that happens, when the sun strikes perpendicular at 23.5 degrees north, that is known as the summer solstice. When the sun's rays strike perpendicular at the Tropic of Capricorn, 23.5 degrees south of the equator, that is the winter solstice. Remember, when you use the term summer and winter solstice, you have to be clear which hemisphere you're talking about, because summer in the northern hemisphere is winter in the southern hemisphere at the same time. So in this case, they're talking about the northern hemisphere's summer solstice in June and winter solstice in December. So let's highlight those to make sure you're clear on those terms. There's also the autumn and spring equinox described over here, and these are also dependent on which hemisphere you're in. So this diagram is important, and it summarizes the 4 key positions of the Earth throughout the seasons. This one's been labeled for you. It's June 21st or 22nd, sometimes it varies, and it is known as a solstice. So you can call it the June solstice, or you can call it the summer solstice in the northern hemisphere and the winter solstice in the southern hemisphere. So you see, if you use winter and summer, it's a little ambiguous. But if you say June, everybody's experiencing June at the same time, so that's a little bit less ambiguous. So in June, the vertical rays of the sun are hitting 23.5 degrees north of the equator, and that is because the Earth's tilt axis is 23.5 degrees tilted from the perpendicular of the ecliptic. Remember, the ecliptic is the orbital plane. So in this particular time, there are more hours of sunlight hitting the northern hemisphere than the southern hemisphere, and so the northern hemisphere has summer and the southern hemisphere has winter. Notice the Arctic Circle here at 66.5 degrees north. They're having 24 hours of daylight in the position shown here. South of the Antarctic Circle, 66.5 degrees south, they're having 24 hours of dark. So the very first thing you're asked to do in activity 2 is look at this globe here and draw those various parallels of latitude. I'm going to do one for you. I'm going to do the Tropic of Cancer. So if you look back at the previous page, in case you've forgotten, the Tropic of Cancer is 23.5 degrees north. So we're going to draw a line and we're going to label it. Notice I did not draw it at 20 north. You have to be careful. It's not at 20 north. It's a bit farther north. You don't have to be exact, but don't draw it on the 20 north line because that would be wrong. And then you can do the rest of these. Question 2 asks you to go back to that figure and write the date of each of those other 3 positions that are not labeled, and then label the circle of illumination, which is the line that separates the illuminated half of Earth from the dark half. So I've circled these 3 areas where you have to put in the dates, and think about the direction that the arrow is showing Earth moving. That should help you figure out which dates should go in each place. Also, this is a solstice and this is a solstice, whereas these 2 positions are both equinoxes. So that should help you with dates as well. The circle of illumination, again, is this night-day line or shadow line that separates day and night. And so the circle of illumination isn't all that visible in some of these images, in others it is. And so you just want to make sure to label that. The next set of questions on this page are pretty straightforward. I don't think you'll have much trouble with them. If you do, you can certainly come to my office hours or shoot me a quick email. One question that people do have trouble with is number 6. It says, would you look towards the north or the south to see the sun at noon on June 21st, 22nd, if you lived at the following latitudes. So let's just do the first one, 40 degrees north. So what they're asking is to look at the position of the Earth on this date. So let's start right there. So here's the position of Earth on June 21st, 22nd. This is the June solstice. And what they're saying is that you live at 40 north. This is the Tropic of Cancer at 23.5 degrees north. So here's a person, and for this person, up is in that direction, perpendicular to the ground surface. To look at the sun, they have to look a little bit to the south from where their position is to see the sun, because the sun is not directly over 40 north, it's directly over 23.5 degrees north. And so you would put that you would have to look south if you were at that latitude. And so you're going to go ahead and do the same with some other latitudes. The next page asks you to look at this table here that gives you the length of daylight at various latitudes and at various times of the year. In this particular question, they're asking you about the length of daylight June 21st, 22nd. And the first one is 90 degrees latitude. So 90 degrees is here. And now we have to decide which of these columns we're going to select. Are we having a summer solstice, a winter solstice, or an equinox during June 21st, 22nd at 90 north? Well, that is when the summer solstice is going on in the northern hemisphere. And so our answer would be 24 hours. There are 24 hours of daylight at the North Pole on June 21st, 22nd. And in fact, there is 24 hours of daylight for 6 months. But remember, the sun doesn't get very high in the sky. Let's try the next one. 40 degrees south. So here's 40 degrees. And on June 21st, the southern hemisphere is having winter. So we don't want to use this first column. We want to use this winter solstice column. And there we go. During the winter solstice for 40 degrees south, the length of day would be 9 hours and 8 minutes. So that's how that works. The rest of these, again, I think you can answer pretty straightforward by looking at the pictures and thinking about the geometry of the Earth and the sun and the shadows. Starting with question 14, it moves on to ask about the March and September equinox positions. And I think, again, that you can answer these pretty straightforward. I will mention number 19. What's the relationship between the North and South poles and the circle of illumination on these equinox days? Well, look at where the circle of illumination is relative to the North and South pole, and that will help you answer that question. We then move on to the lab report, where I've assigned questions 2 through 6, 9, and 11. And a little bit of a warning for number 5 here, where I'm asking you to draw a picture. It asks you to draw the Earth relationships on June 22nd, and it says these should all be labeled. Now, I commonly have students do the following. They go back to this picture, and they say, oh, there's June, and they draw the exact same picture. The problem is, in this diagram, the sun's rays are coming from the left. In this picture, the sun's rays are coming from the right. So this is not going to be correct. So you need to think about the orientation of the Earth given the fact that the sun is coming from the left. And the circle of illumination, I will tell you right now, is going to be perpendicular to those sun's rays. I didn't do that very well. But this is going to be the nighttime side, right? This is going to be the side that's dark. That's it. I hope that helps, and good luck. This was a pretty quick lab. Next 2 labs are going to be a little bit more time consuming, so make sure you get started on them early.